So continuing on with some limits, we're kind of messing with some techniques. And in general, if we have a rational function, which is what we're about to do, we want to make sure that the value that we're plugging in is not a domain issue. If it's not a domain issue, we just plug it in. So if I, just a real quick kind of, if I plug that 2 in, is it going to cause 0? That's all I'm really looking for. So if I do 2 cubed, that's 8 times 5 is 40. 40 minus 36 is not going to give me a 0. So to me, x equals 2, which is the value that we're plugging in, is not a domain issue. So if it's not a domain issue, plug it in. So plug it in. And that's it. We don't have to do anything special. We just plug it in, see what we get. So for our limit, as x approaches 2 on this function, x cubed minus 36 means we are doing 3 times 2 squared minus 4 times 2 divided by 5, 2 cubed minus 36. And let's just see what we get out of that. All right, so we have 2 squared is 4, 4 times 3 is 12, minus 8 for your numerator. This was 8 times 5 is 40, minus 36. We're looking at a 4 over 4 equals 1. So I could check that visually by graphing this equation and just kind of seeing what both sides of the graph are approaching at 2. They should both be approaching the y value of 1. Right? And then we'll do this one. See what happens on this one. First off, definitely 2 is not a problem on that. So same kind of explanation here. X equals 2, again, is not a domain issue. So plug it in. All right, so for us plugging it in, we're going to plug that into this. So let's not rewrite it. Just do the math here. So you got 2 times 2 cubed plus 9, then plus 2, 3 times 2 minus 1, all on the outside divided by 4 times 2 plus 1. All right, so we have 8 times 2, looking at square root of 16 plus 9 plus 6 minus 1, all divided by 8 plus 1. Okay, so that's going to get us a square root of 25. And then 6 plus 6 minus 1, all over 9. Oh, let's just do this stuff. That one's going to be 6 minus 1 is 5. So we have a 5 minus 5 plus 5 divided by 9 gets us 10. All right, so again, if we graph this thing, we plug it in or we graph it, we look what's happening around 2, we should be approaching from both sides the value of 10 ninths. All right, let's do one more. For example 5, find the following piecewise. Now, piecewise is different. Piecewise has very strong potential that there's a break, right? The left side doesn't line up with the right side. They can, but they may not. So for the following piecewise function, find the values, the limit. So we really need to look at the left side and the right side and see if they match overall. And if they do match overall, then we actually have a limit. If they don't match, then we don't have. So I have absolutely no idea. I don't necessarily need to graph it. I could graph it. That would be good. But I could also just do this, plugging in the left and plugging in the right. So if I do the limit as x approaches 1 from the left of this function, so the left would be values that would be smaller, which would be this. We want x's that are less than or even equal to 1. So we're doing a less than if we're doing 1 from the left. So we're taking this negative 2 times 1 plus 4. All right, so we're assuming we're infinitely close to 1. We're just going to plug in 1. All right, it's not a domain issue. It doesn't cause a problem on the linear. It's not going to cause a problem on the square root because we're not going to get a negative on the inside here. So we're good to go. We can plug it just straight into both. So math on this is we got a negative 2 plus 4. So this value is approaching 2. All right, so then we're going to look at the other side. The limit as x approaches 1 from the right means now we're greater than. So we're going to be doing square root of 1 minus 1. That turns out to be, extend that all the way. And then we're going to get a square root of 0. Square root of 0 is 0. All right, so as the limit as x approaches 1 to the right is actually approaching 0. So they don't match. So visually what you got going on is just a real rough idea is here's 1. 1 is that transition from the linear graph to the square root graph. And whatever this is, you got a graph that's going down and it would hit a value of 2. Right, and so we'd have a closed circle. It would be doing something like this, right? It would be moving along, and ends at 2. And then this graph starts off, it's a square root kind of a graph, and it kicks off at 1. The y value is 0. You have an open circle, and then it does some sort of a graph. Whatever it looks like, doesn't matter. Because all we care about is what's the left side approaching, what's the right side approaching, do they match? Nope, we didn't need the visual for that because they didn't match. So for our answer of what is the limit as x approaches 1, then they don't line up. So it is a does not exist. And that is our final answer. So we have the limit as x approaches 1. We have the limit as x approaches 1 from the right. We have the limit as x approaches 1 from the left. All right, and then we're going to go into some other techniques and a little bit more rational problems, but rationals that have domain issues. So then how do we deal with that? Right, we'll do that in the next video.